All right, here we go with the second half of Chapter 3, Sections 5 through 7. So first thing first, you're going to open up Desmos. We're doing a lot of work in Desmos today. And if you didn't watch the previous video, you're going to want to do that because it goes through how to download and save copies of the work that you're doing, because we're going to be doing that several times today. Also, a good idea to keep track of where your images are being downloaded to. And then I would also recommend at some point going in, clicking on the download. Instead of calling it a download file, call it something else like CH3-5 for section 3-5, or something with your last name, something related, so when you're going back to find them to upload them for the assignments, you can access them quickly instead of having to go through and looking at all the video or all the images, or making the mistake of uploading the wrong file, which you should be, you're responsible for that at this point. So when Desmos is open, here's what I want you to do. There's going to be a lot of slides that are along these lines, so the video itself isn't very long, but each time you're going to want to stop or pause the video, look at these things, do them, follow the directions of what I say to do, then do the download, etc., etc. So use pause commonly. So here, first thing I want you to do, graph the following all in the same graph, and then you're going to download that graph. All right, so you're going to graph these equations. Y equals 1 over x, y equals 3/2 x. Remember, for something like this, it's fairly quick. When you're typing it in, you're going to type y equals 3 divided by 2x. And then what happens is Desmos will automatically bank that into a fraction as 3 over 2. And you'll see that happen. Keeping track of your negative signs as well. So you're going to graph all 4 of these on the same graph. All right, and then you need to be prepared to explain, which means it would be a good idea to write it down as you go along. Graph one, then graph the next, then graph the next. And as you see what's happening, what's the same and what changes. So with every change in the graph, what's going on? In other words, what happens when the coefficient changes? What happens when the constant changes? So you're trying to start to think like a mathematician in terms of if you had to have a general rule, what would that be? So pause this video, do that now, and when you're done, hit resume and it'll go on to the next slide. So now what you're going to do, you're going to create a new graph in Desmos so that the previous ones are gone, so either erase the other ones or do a new one, and graph the following all together, all 4 of these on the same one. So this is the absolute value symbol. In a standard keyboard, it's usually right underneath the delete key, so shift, it's a shift /, but it gives you the vertical line for the absolute value. Graph this one, and then also this one, and then this one. Notice in each case, one thing changes from here to here. It goes from just x to x minus 1, and then from x minus 1 to x minus 4, and then here it goes to x minus 4. So you're going to see what happens. And again, write a couple sentences in your notes at this point, explaining what you see is happening. Make it sense to you. Math is the study of patterns, so then something else you might want to consider is, what if these aren't all negative? Then what happens? Or if we're graphing this, what if this number is negative? What if it's negative 2x minus 4? And if you want, you're welcome to put 2 more graphs on there to make a bigger graph if it's going to help with your understanding, the explaining that you have to do. And then again, if you're thinking, if you had to make a rule for absolute values, what would that rule be? I don't ask these questions rhetorically. I'm actually wanting you to stop, do these, write down several sentences, more than a couple, because there's going to be a lot going on, so that you can explain what to do. So when you're done doing this, and that you've downloaded this for use later, go ahead and hit play again to go on to the next slide. If you happen to be hearing some noise in the background, I'm recording this in the coffee shop, so it's picking up maybe some of the other people and voices that are out there. But what I want you to do now is, again, start with a new one, and now notice what's different here. Now, instead of inside the absolute value, we're adding constants outside the absolute value. This one and then this one, absolute value, then plus 2. So just making sure that you have the absolute values just around the x, and then here from here to here, now we put 1 on the inside. So hopefully this follows the rule that you wrote on the last page. But when you're doing this, again, looking for patterns, how would you explain what you see happening? You're going to download this to submit it later. And again, if you have to make a rule about absolute values, what would it be? So in the previous slide, it was all based on things that happen inside the absolute value. Now we're doing things outside the absolute value, pluses and minuses. Take some time, write that down, make a prediction to yourself. Think, well, I wonder what would happen if. Maybe try that and see if it follows your rule. If not, maybe you have to adjust your rule. When you're done doing this slide, making all those graphs, writing all your explanations, go ahead and hit play and see the next slide. You guessed it, but this time, what I want you to do is don't use Desmos at all. Just look at this equation. I want you to write down a couple sentences with your guess of what do you think this graph would look like? How could you describe, based on what you see happening outside the absolute value, inside the absolute value, and this number in front of the x, what effect will that have, and what might that graph look like? Like, really take some time. I don't want you to plug numbers in. I don't want you to actually graph it. I want you just to think and then write down what you think it will look like using math language as you go along. When you're done doing that, hit play for the next, or hit pause now, then hit play for the next slide. So now I actually want you to go graph it with Desmos and see if your guess was right. How does it compare to what you said? Were you right? If you weren't, what was the difference? Which components of this, as you're thinking through, which ones make more sense and which ones are more challenging to remember about these generalized rules that you're doing? So now, without using Desmos, what do you think this graph will look like? Notice that it's the exact same as the other graph. From here to here, it's the exact same. The one difference is this is a -2 now out in front of the absolute value. What do you think will happen? Write down a couple sentences with your guess. Hit pause, obviously. Write some things down. And then you're going to come back and, well, you'll see what happens on the next slide. Notice I did not say go and do it in Desmos. So now I want you to say, okay, this is the exact same as the other one, but the one thing that's different, instead of equals, is now greater than or equal to. What effect does that have? Again, writing down a couple sentences with your guess. Now, if you did graph the last one, you'll know what it did look like and does look like. So now you can think, all right, well, what is this going to be? And this, again, is all about studying patterns. What do you think is going on? What am I predicting it might happen next? Because the better you get at this, then we're working on other problems. You're going to have a general understanding of what's going on first before you do any actual calculation, and that actually makes you a much better mathematician. So when you make mistakes, because we all do, you can see a result and go, wait, something's not right, and go back and find out where you made your mistake. How about this one? Different symbol. What is that going to appear as? How is that going to look? Take some time, write it down, hit play for the next one when you're done. The other reason why we're doing this is that Desmos is not available, will not be available on exams. So what are you going to have to do to start preparing so that you can construct graphs like this by hand? Yep, by hand. So now you made all of those assessments with the absolute values, with the greater than, less than, greater than or equal to, less than, equal to, versus just an equal to sign, and you're thinking through again, what does that all mean? So if I see a symbol, what does that automatically mean when I go to do my graphing? What will that appear as when I do my graphs? When I have values inside and outside the absolute values, if I have a number in front of the x. So here's what you're going to do. This is the actual assignment piece. You're going to write about the general rules that explain how to graph absolute value equations in the text field for the assignment. All right? Include a sentence or two about what to do with inequalities as well with respect to these equations. So we're talking about many, many lines of writing that go into this. Also reminded, capitalization, grammar, should be without any errors. You're capitalizing at the beginning of sentences, you're using punctuation as you go. If you're using math symbols, you're using them correctly. Mathematical terminology used correctly. This is all going to be done in writing. Your uploads or the downloads that you made from all those different things that you created, those are for your reference. So pull those up, look at them, and as you think about what you see in those graphs, that's what's going to help you with your explanation for what you see. But do not upload a picture. Also, do not write down all your information and try to upload a picture of that. I will not accept that. It must be your typing that goes into the text field. All right, and yes, there are plenty of resources online where you can find assistance with these, but this is not a copy and paste activity. It's very obvious when people choose documents from online or resources from online because they write as professional mathematicians as myself, and we know we talk different than students, so using your own language, your own voice, as you try to explain how all of this works. That is the assignment portion of this that will be due. We'll go online and it shows you the due date in Canvas for this one. Make sure that you've submitted your responses prior to the deadline. Don't miss it. And then lastly, outside of class, this is our 1.5 hours of inside of class time. For the 3 hours of outside of class time, this is what you're doing. You'll notice for these 3 sections, there's far fewer problems, maybe like 17 total. It's meant to be much less because we did a lot of it in class through Desmos and just getting a good handle on what's going on here. Checking your understanding, which means you're going to go and look for the answers in the back after you've done them. If you don't get the right answer, go back and fix your problems because you are responsible for knowing or not knowing that you know or not know these things. Lastly, read chapter 4, and yes, I mean the whole thing before we come to class the next time we meet. That is all for this video. I will see you soon.